All right, here's a second part to that equilibrium where we're going to look at a few different situations. And this is a situation where an object is hanging in equilibrium and being pulled by three different ropes. Okay, it's like a tug of war situation. All right, and often you're going to be asked to calculate not just the force of tension in one of the ropes, but also the angle at which it is pulled in order to maintain that equilibrium. So a very common situation. So how do we go about calculating the force of tension in rope F2 and that angle when these are provided for you? Okay, and really what's happening is this object is in two different equilibriums. It's in an equilibrium along the x-axis, and it is in equilibrium along the y-axis. Okay, so in order for it to not be moving horizontally, it's being pulled by 20 newtons in that direction, which means that this object has to be pulled by 20 newtons in the opposite direction in order to maintain that equilibrium. Okay, and likewise, in the y direction, okay, this object's being pulled down by gravity, which means that that rope has to be pulling up with equal and opposite strength, the force of gravity. Now you can see this arrow is a lot shorter than that arrow, which probably means that this isn't drawn to scale. That probably should be a little higher of an angle. All right, so I can say that that's going to be opposite sign of gravity, and this will be negative 20, so it's equal and opposite. So as long as I'm able to solve for the force of gravity, and I have that, I can probably use Pythagoras' theorem to solve for the force of tension, and I can use trigonometry to solve for that angle. So let's go about and do that. Okay, so here I have just that situation drawn for you where this is going to be 20 newtons, and if I solve for the force of gravity, 10 kilograms times 9.81, that should be, I'm just going to round up, it's about 100 newtons. Okay, so I have 100 newtons of force upwards, 20 newtons of force to the left. Okay, so to solve for FT2, okay, we have a squared plus b squared is equal to c squared. I can use that to solve for FT2, where 100 newtons squared plus 20 newtons squared is going to be equal to FT2 squared. Okay, and to get rid of this square, I got to square root that side, and I'll do that to the other side. So the square root of 100 squared plus 20 squared is going to be equal to FT. So if you go ahead and solve that, I'm not going to put that in my calculator, but 100 squared plus 20 squared, you take the square root of that, that would give you the force of tension 2. Now, how do we solve for the angle? Well, the angle is going to be, this is opposite, and that's adjacent. So tan theta is equal to 100 newtons over 20 newtons. Okay, theta is equal to tan. Okay, and that should give me my angle, okay, that you'd be able to solve. I think 100 divided, yeah, that's about right. And that should give you that steep angle that is being applied. Okay, so again, in order to solve that, you have to understand that the equilibrium works in the x-axis and the y-axis. So whatever force they gave me, it'll be equal and opposite. Whatever force they gave me, it'll be equal and opposite in the vertical direction. So now, a harder level problem would be they give you some forces, they don't give you everything. So now we want to solve for the force of tension in that angle, in that rope that is being pulled at that unknown angle. Okay, so again, this is just a little bit more difficult, okay, because it was a lot easier when one of the forces is horizontal and vertical, but now I have two forces acting at an angle, so this is a little bit more challenging to solve. In order to do that, I have to write out some equilibrium expressions. Okay, so to solve for this thing, okay, I have to write that it must be in equilibrium in both the x and the y components. That's my Cartesian plane. So for the x component, how would I create a statement? Well, in the x component, I have that component force being balanced by that component force. So how would I create that statement? Okay, so I have an angle here and I have a force here. So for the red one, it's pretty easy. Okay, this is my adjacent, and that's my hypotenuse in a right-handed triangle. So that would be a cosine function. Okay, so for the x-axis, I would have cosine cosine 37 degrees times 29 newtons. Okay, that's going to give me the force in the x direction going in that direction, which is going to be equal to, okay, whatever this force is going to be. Okay, so how does that relate? That's also the cosine. So this is going to be cosine of theta times F1. Okay, or I can just say it's equal to my Fx in that direction. Okay, so I just created a statement. So this force, which I can calculate, cosine of 37 degrees times 29, is going to be equal to the force in this direction. So I can even write that here. That's cosine of 37 degrees times, okay, which is a number. So I'd be able to get that number at least. Okay, so that's great. So if I have a number here, I just need, like in the last problem, to solve the vertical component on both sides. Okay, so how does this work out? For the vertical component, it's a little bit more complicated. The vertical component here plus the vertical component there is going to be equal to 22 newtons. Okay, so how do I solve for this vertical component? Okay, well, the vertical component here, that's opposite, and that's hypotenuse from the 37-degree angle. So that's opposite. So for my vertical component, we have sine of 37 degrees times 29 newtons plus, I'm just going to say sine of theta times F1 is going to be equal to 22 newtons. Okay, so here's something interesting. All right, I could solve for this number, okay, and I'd be able to find out what that force of tension, okay, because that's my force of tension. I'll be able to find out that that'd be 22.0 newtons minus sine of 37 degrees times 29 newtons. Okay, so once I've done that together, let's just quickly solve that on our calculators. Sine okay, and that gives us 4.55 newtons. Okay, so that means this is 4.5 newtons. Okay, and then in that case, I have, sorry, this is 4.5 newtons right here. Okay, so 4.5 newtons I will have here. That's pulling up at 4.5 newtons. Okay, and I have the x component, so then you do the same thing. So a squared plus b squared is equal to c squared, and I'll be able to solve for F1. Okay, so then a squared plus b squared. Okay, how do I solve that? So fx is going to be equal to this. Okay, so let's solve for that. Cosine of 37 times 29. Okay, that's going to be 23. Okay, so then 23.2 newtons squared plus 4.55 newtons squared is equal to c squared. So then the square root of 23.2 newtons squared plus 4.55 newtons squared is equal to c. Okay, so if I do all that, left with 23.6. Okay, so this should be 23.6. And then with that number, I should be able to then solve what this angle is going to be using trigonometry. I can also use just this number, 4.5. So tan theta is equal to 4.5 over that, and I'll be able to get you the angle. Okay, so tan theta is equal to 4.55 over 23.2. Theta is equal to 10. Okay, which is going to be equal to 11.1 degrees. All right, and that's how we solve that last hard problem.